Welcome to your first PowerPoint of the year in Math 5 CST. We are going to start with System of Inequalities, which includes putting together both the systems of equations that we reviewed and the inequalities, graphing the solution set, other related questions to systems of inequalities, as well as obviously exceptions. There needs to be exceptions whenever you do anything in math, so that's what we're going to go over right now. What is a system of inequalities? Basically, when you're given two inequalities and you need to find where, if possible, their shading intersects. So you should know by now how to shade above or under a line. In this case, you're given more than one line and their shading might intersect somewhere. The thing about this is that you actually can't use a systems of equations method like comparison, substitution, elimination to solve these kinds of inequalities. For example, given two inequalities, find the points that simultaneously, so at the same time, make these inequalities true. So if you're given two inequalities, don't say to yourself, okay, I'm going to do one of the systems methods like comparison method. No. In this case, it's better to try and graph them. Let's try graphing the first inequality, which you should already know how to do. We have 2x is greater than 3y. You should isolate your y to make it look like 2x over 3 is greater than y. Then you make it into a linear equation with the equal sign and you graph it. This you should know how to do. Your graph will look something like this. As you can see, there is no b, so it passes through the 0. And knowing your slope, you plug in some points, put it along the line, make your line. I also want you to note here that my line is dotted because my inequality is just greater than. There's no equal to. So we are going to use a dotted line. Now we graphed the inequality. We now need to know where to shade. So originally we had something like this, but I'm not really good at knowing where to shade when my y is on that side. So I'm just going to flip it. I'm going to have y is less than 2x over 3. Because y is less than, we shade under the graph, as you can see here. Do it yourself. Graph the second inequality. So I give you this inequality, x plus 6y is less than or equal to 12. Do it yourself. Follow the steps. Isolate y, make into a linear equation, and then shade. Of course, graph first, and then you shade. Make sure your line is in the right format. By right format, I mean, is it dotted or is it solid, depending on the inequality. This is what you should have got, something that looks like this. I have a negative slope and I have a b that's 2. So as you can see, my graph passes through 2. My line is also solid because it's a less than or equal to inequality. And because it's a less than or equal to, you shade under the graph. The solution for the system of inequalities is where the shading intersects. So we shaded the first inequality, you shaded the second inequality. So let's put it together. Given the two inequalities, 2x greater than 3y and x plus 6y less than or equal to 12, this is where their shading intersects. So all I did was I superimposed both of the shading that we did, one on top of the other. And as you can see here, where the purple meets the yellow is down here. And this is called the solution set. For this chapter, we're going to call this the solution set. So any point where these intersect is what will make both of them true. Which coordinate, or we're going to call it an ordered pair, is part of the solution set of this system of inequalities? So here is the shading, but I've also added 4 points and random parts of the graph. I want you to tell me which of these points is part of the solution set. I have here 2, 4, negative 6, negative 2, 4, negative 4, and 8 and 2. Which one is part of the solution set? This one is part of the solution set because if we look at this point here, 2, 4, it's not even in any of the shading. This negative 6, negative 2 is only in the blue shading. This 8 and 2 is in the yellow shading. Whereas this one here, this 4 and negative 4, is in the intersecting part of the shading, also known as it's in the solution set. Do it yourself. Represent the solution set of the system of inequalities that I'm about to give you. So show me where the shading intersects. You're going to need some graph paper for this. After you do that, find 4 ordered pairs that are part of a solution set of this system. Your first inequality is y is greater than negative 3x plus 4, and y is less than or equal to 1/2 x plus 5 over 2. This is what your graph should have looked like after you had done the shading and the line. If you notice, the green one has a dotted line because there's no equal to on the bottom. So it's also greater than, so we shade on this side of the line. Whereas this inequality here has a less than or equal to, so it's solid. And our shading is under because it's a less than or equal to. Now, when I ask you to find 4 ordered points that are in the solution set, you can pick any 4 points that are in this solution set here, where the graph intersects its shading. Now, I picked these 4 just randomly, but you could have picked any other ones. It doesn't matter, as long as your points were in this solution set. So now we're going to see some other kinds of questions that you might see on a test or a quiz or just your homework based on system of inequalities. One of the questions you might see is to find the system of inequalities of the solution set, meaning they are going to give you the lines, solid, dotted, whatever. They're going to give you the lines, and they're going to give you, say, a part of this graph, and they're going to say, what is the system of inequalities for this part of the graph? So I'm going to label the parts A, B, C, and D. We're going to call these the regions. So here are 2 lines of a systems of equations, and their boundaries are separated into 4 regions, as you can see, A, B, C, and D. So what are we going to do with these regions? One of the questions could be, write a system of inequalities whose solution set corresponds to this region A over here. Step 1. Region A we know is bounded by the green and the purple line, or blue line. In this case, what can we say about the green line? It's a solid line. That could help us with the inequality. And secondly, A is on top of this green line. So we can say that this A is bounded by the first inequality, y is greater than or equal to, because it's solid, negative 0.8x minus 2. So you see where we're getting at here. They don't give us the inequality. You have to say what is the inequality, and in this case, for region A of the green line. So how do you think we can make the blue line into an inequality for region A? We'll do the same thing. First, the blue line we see is dotted, so that tells you something about what the inequality might be. Secondly, region A is on top of the blue line. So knowing when to shade on top and on the bottom, you should write the second inequality as y is greater than x plus 5. Greater than because it's dotted, but greater than because it's also on top of this blue line. Now what if you're not sure? What if you're not sure that you got your inequalities right? You can always check your work. Pick a point in region A and see if it makes both of the inequalities true. So in my case, I just picked point negative 4, 6. If I plug it into my first inequality, I get 6 is greater than or equal to negative 0.8 times negative 4 minus 2. And I get that 6 is greater than or equal to negative 4.7, and that seems pretty reasonable. For the second one, taking the same point, I get 6 is greater than negative 4 plus 5. 6 is in fact greater than 1. Both inequalities are true, so we have the right systems of inequalities for region A. So the system of inequalities whose solution set is region A, so the answer that you would have to give is y is greater than or equal to negative 0.8x minus 2 and y is greater than x plus 5. It's up to you now to do the exact same thing for regions B, C, and D. And these are the answers that you should have gotten. For region B, you should have got that the green line is less than or equal to, and that the blue line is greater than. For C, your inequality for the green line is less than or equal to, and for the blue line, it's just less than. And finally, D, your green line is greater than or equal to, and your blue line is less than. The second kind of question that you'll probably see along the way will ask you to find ordered pair solutions for this system of inequalities. So here's a system of inequalities, and I'm asking you, don't even graph them, but can you find two ordered pair solutions, 2 points, 2 coordinates, whatever, that make both of these inequalities true? Here's the system of inequalities. I'm just going to try 0, 0. You can never go wrong. It's a lot easier to use 0, 0 because it's easy to calculate. So let's just see if it's an ordered pair in the system of inequalities. If we plug it into both of them, we get something that looks like this. 0 is greater than or equal to 0 is greater than or equal to 9, and 0 is less than -4. Doesn't seem to make too much sense for the first one. So these inequalities are not true. So now we can cross off 0, 0 as an ordered pair in the system of inequalities. You will have some ordered pairs that might make half of the inequalities true, but we want a pair or a coordinate that will make both of these inequalities true. Can you try finding 2 ordered pairs? Just to give you an example, here are some ordered pairs in the solution set of the system of inequalities. I have 2, 2, 14, 20, 6 and -10, 5 and -15, but you could have found way more and other ones that I haven't mentioned. Pretty much, if you wanted to, you could have graphed it, any of the ordered pairs in the solution set here. So I graphed basically both of the lines that I had given you for the system of inequalities. So any of the ordered pairs found from here all the way down, it would be an ordered pair that would make the system of inequality true. Just a special note. You can pick an ordered pair that is on a solid line in the solution set. For example, 1.6, -4 here is a point on the solid purple line. Does it satisfy both inequalities? If we plug it in, -4 is greater than or equal to -3.8 and -4 is less than 5.6. It works, but it doesn't work for a dotted line. Finally, we have some special systems of inequalities because there's always some exception in a chapter. The first exception, when there is no solution. Say you're given 2 inequalities and you graph them. Notice that they are not intersecting at all. Notice also that their slopes are the same. So we got 2 parallel lines. There is no solution. So the shading doesn't intersect because there's no solution. And in mathematical speak, and it's very important that you remember this because it is in your homework, this is called the empty set. So the set or the solution set that has no solution. It's empty. It's white. This is called the empty set. That's the first exception. Second exception is when the solution set is exactly along one line. So notice that we have 2 inequalities that have the exact same equation. Just one is less than or equal to, whereas the other one is greater than or equal to. So their solution set is all along this line. So these are both the same linear equation meeting at one solid line. So you could just say that the solution set is just points along this line. Y is equal to -7/3x minus 2/3. The third exception is when the solution set satisfies just one of the inequalities. Here are 2 inequalities graphed, but if you notice, it's really only the top of this line that we care about because that's where they intersect. So because this is the solution set, it's just the half plane. There's not any fancy intersecting going on. It's just the region above this line. So we can therefore say that the solution set is simply the ordered pairs in the solution set y is greater than 0.4x plus 6. Finally, your last exception, when the solution is located exactly between two lines with the same slope. So this is the opposite of the empty set. We have the same slope, but instead, this would have been the empty set in the first exception is actually the solution set. So because this is the solution set, we just leave these as is, and the ordered points are just along these two parallel lines. So to recap, systems of inequalities require you to be able to graph inequalities, choosing the right line format, and shading the right regions. The region where the shading intersects we call the solution set, and that's what we care about. If you're unsure about your shading, you can always pick a point, also known as an ordered pair, and try it in both inequalities to see if you get a true answer for both inequalities. You should not forget about the 4 special systems of inequalities that I just showed you, because you can bet you'll see them often. And that is the end of 1.1 System of Inequalities. Our next chapter is using systems of inequalities, but we call them polygons of constraints.